Here we have a short video for Newton's third law. As you're going through third law problems, keep in mind the simple concept that we looked at in our first lab, where you pushed with the scale on a partner in a rolling chair who pushed on a scale as well. And when you pushed, even if your partner tried not to push, their scale always read a value greater than 0, indicating that there was always a reaction force. So for every push, there's a push in the opposite direction. That's the idea of third law here, is that every force has an equal and opposite reaction force. So once we have that force, we can calculate acceleration. Now, if you had, say, an offensive lineman from the 49ers and a small freshman from Sacred Heart conducting that experiment, the forces could be equal and in opposite directions. However, the offensive lineman is much more massive than the freshman, so we'd expect the offensive lineman to accelerate far less than the freshman. So that's why sometimes people think that the forces on the two objects are different. So we're going to go through this first one. For each of these problems for homework, I want you to draw an interaction diagram, draw a quantitative force diagram for each of the two objects. Now when you do this, remember your interaction diagram shows you the arc is between the objects in the force pair. The quantitative force diagram, quantitative means include quantities, amounts for each force. Remember how to label them. So we'll go through that in a second when we do the example. Calculate the value of the forces involved in the force pair, meaning the action force and the reaction, and then calculate the acceleration of the object in bold. So here we have a boxer's fist, kilograms, punching a punching bag that's 10 kilograms. We find that the punching bag accelerates to the left at 3 meters per second squared. So I've gone ahead here and drawn my interaction diagram. Remember the steps. We have the ground below them. The punching bag may be swinging slightly from the ground, so it might be a little bit higher than indicated here. And then we draw the earth below. We differentiate between the earth and the ground because the ground applies forces like normal force and friction, whereas the gravity is a result of the total mass of the earth, not just the ground right below us. So once we draw our objects, we indicate an arc between the two objects involved with any force. And then we write the letter of the force, so G being gravity, the gravity between the punching bag and the earth. This lets us know that there's a force pair between the earth and the punching bag. So each one of these arcs, 1, 2, 3, 4, 5, 6, and 7, is a different force pair. So we could identify 7 different force pairs here. Because for every force applied to one object, that means that object is then applying the same amount of force in magnitude or amount, but in the opposite direction to the other object. So here we have normal force, tension force, friction, and gravity being our only non-contact force. I also added the acceleration up here just to give you a visual of what we're looking at in this problem. We know that the punching bag accelerates this way at 3 meters per second squared, and then we want to see the fist going this way. I made the fist a bit bigger just to exaggerate it here. A boxer with a big fist with his punching glove on, there. So after our interaction diagram, we'd circle the object that we're interested in for our force diagrams. Let's look at what the work would look like on calculating the force involved. If we know the mass and the acceleration of the punching bag, we know acceleration is force over mass. So we know that if we solve for force here, force would equal mass times acceleration. We were given the mass of the punching bag being 10 kilograms, the acceleration being 3 newtons per kilogram, or 3 meters per second squared. Remember, both of those units work for acceleration. So 30 newtons to the left. Now, Newton's third law tells us the normal force of the punching bag on the So Newton's third law tells us that the force will equal the mass times acceleration. So we get 30 newtons of force to the left. Now we know the normal force of the punching bag on the boxer is equal to the opposite of meaning the opposite in direction of the normal force of the boxer on the boxer from the punching bag. So remember we say the type of force N, that's normal, the object that it's applied to, the punching bag, and the object applying force, the boxer. And then if the boxer hits the punching bag with 30 newtons, the punching bag hits the boxer with 30 newtons is what we're saying in words. So once we know that, we can apply that to find the acceleration of the fist, the boxer's fist. So 30 newtons to the left means the punching bag pushes the fist 30 newtons to the right. However, we have a different mass for the fist. The fist is 1.5 kilograms. So the force on both objects is the same, but in opposite directions. However, the mass is different, so their accelerations are going to be different. The fist is far less massive, so it's going to accelerate more to the right. We see that as slowing down, since the fist is moving to the left and then slows down. Let's look at the force diagrams. Here's what our two force diagrams would look like for the situation. Notice that there is a difference between paired forces and forces that balance out. Paired forces will never be in the same force diagram because they're never acting on the same object. It's always, a paired force is always the object receiving the force also acting on the object that was giving the force. So here our paired forces are this and this. Now just to go quickly back over this, I think earlier I had this mislabeled up above with the paired forces. So this is saying the normal force on the box, on the bag from the fist is 30 newtons. This arrow indicates the left. If we didn't have the value, we'd have these three lines indicating that it's equal to this force over here acting on the fist. So the normal force on the fist from the bag. So these are paired forces. The fist hits the punching bag with 30 newtons of force to the left. The punching bag hits the fist with 30 newtons of force to the right. That is what Newton's third law means. Here's how we would write it. So we're saying the normal force on the bag from the fist is equal in amount, but the negative indicates opposite direction to the normal force of the fist on the bag. So what we did here is then we used that fact in knowing what their accelerations to calculate acceleration based on mass. So we find out the acceleration and we know the mass of the punching bag. We solve for the force. We plug that in for the fist with this new mass to find its acceleration in the opposite direction. And that's the same thing you're doing for the other four problems.